The last type of bonding that we will discuss is metallic bonding. Metallic bonding is different than covalent or ionic bonding because it is an attraction between a positive metal ion and the many electrons surrounding it. And the more valence electrons an atom can add to the sea of electrons, the stronger the metallic bonds will be. So bonding between metals is completely different than bonding between a metal and a nonmetal and two nonmetals. So in metallic bonding, metal atoms combine, don't comb, in regular patterns in which the valence electrons are free to move from atom to atom. This image of aluminum foil up close gives a slightly better perspective about what I mean when I say the sea of electrons. So metals act this way because the positive ions are attracted to all of the loose electrons that are around them that are coming from the other metal ions. And because metals bond in this way, that is what leads to its properties, including things like malleability and ductility. We know that most metals are flexible. We know that they can be pulled into a long wire. We know that they can be shaped and reshaped quite easily, in fact, and that is simply because of the way that metals bond. Luster, for example, the fact that metal is shiny and reflective, is due to the valence electrons, because when light strikes the electrons, they absorb the light and then give it off again. The fact that metals conduct electricity is due to their bonding as well, because they conduct current easily because the electrons in the metal can move freely among the atoms. They are also thermally conductive because the valence electron's freedom of motion with a metal or metal alloy allows for the heat to be transferred well. Finally, you've heard me mention a few times metal alloy. An alloy is simply the special word we use to describe a mixture, so remember the difference between a mixture and a compound, that is made of two or more elements, and at least one of those elements is a metal. So you'll often hear metal alloys referenced. Stainless steel is an example of an alloy. It is a combination of iron, carbon, nickel, and chromium. We create alloys because they allow us to mix different metals with nonmetals in order to create the specific characteristics we'd like. For example, brass is another type of alloy.